All right, guys, we're going to do some more solving equations, obviously with logs. Um, there are different types of log equations. The first type is when we just have a single logarithm, a single log. Okay, there's not two or three logs, just one. All right. Most of the time when it's a single log, we just rewrite it. We're going to rewrite it as an exponent. Okay. So this is, hey, there's no base, right? If there's no base, then we know it's the common log. It's log base 10. We just don't write it. Just like we don't write x to the first, right? It's just understood that it's x to the first. We don't write 1x. It's understood when I see x that the coefficient is 1. It's understood that when we see x that the exponent is 1. We don't write some things that are very common, okay? If we don't see the base, we know that it's a 10, okay? The definition of a log that you really want to get memorized is that the log base a of x equals y is the same exact thing as saying a to the y power equals x. These two statements are exactly the same. So I can rewrite this. Another way of saying that log base 10 of x minus 3 equals 4 is to say 10 to the fourth equals x minus 3. Okay, that's how you say it without the word log. All right, so then 10 to the fourth is 10,000. So I'm just going to add 3 to both sides. And my answer to this log equation is 10,003. Okay, so you just, if it's a single log, we just rewrite it as an exponent. All right, so let's try this one. Try this one on your own. See if you know how to set that up. Okay, it's log base 10. So we're going to say 10 to the third equals 2x plus 1. Okay, 10 to the third is 1,000. Right? And then we just subtract 1. 999 equals 2x. Divide by 2. So we get, whoops, divide both by 2. We get that x equals 999 divided by 2. You can just write it like that if you want, 999 over 2. Or you can write it as 499 and a half. You know, I mean, it can't simplify. So I either write this or 499 and a half or 499.5. You know, it's up to you. 999 over 2. All right. That's one. Now, if there's more than one log, then what we're going to have to do is use those properties that we learned last chapter. So when I see two logs added together, I know that's writing it as a single log of the product. Does that make sense? Remember, when I have two logs added together, I can write that as a single log of the product. Now, what's great is I have log base 2 of this is supposed to equal log base 2 of that. The only way that's going to happen is if this equals that. I can drop the log once I have log of this equals log of that. I just set those two things equal to each other. So I have x squared plus 2x equals 6x plus 1. I'll subtract everything over here. Subtract the 6x from the 2x. Subtract the 1. I have x squared minus 4x minus 1 equals 0. That doesn't factor, so I'm going to say 4 plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's 4 plus or minus the square root of 16 plus 4. What's that, 20 over 2? 20 is 4 times 5. I can take the square root of 4, so I'll bring that. Square root of 4 is 2. Okay, and I can take 2 in each of those, so my answers are 2 plus or minus the square root of 5. Okay, notice I do have check your answers. We're not going to be able to have a negative number. Remember, the domain of the log function is 0 to infinity. So if I take 2 plus the square root of 5 on my calculator, that gives me, 2 plus, the square root of 5 is 4.2-ish. So that's fine. 4.2, 4.2, that is fine. That gives me a positive answer everywhere. 2 minus the square root of 5, though, gives me negative 0.23. So that's not going to work. All right, so therefore, that's why I said check answers. You can't have negative, you can't take the log of a negative. So my only answer is 2 plus the square root of 5, not 2 plus or minus the square root of 5. All righty. Next one. Log of a difference is the same as the log. 2 logs subtracted is the same as the log of the quotient. Okay. Now, unlike this one where I had the log of this equals the log of that, this is just one log now. When there was one log, we said that we would rewrite it. So log base 10, I'm going to rewrite this as 10 squared equals x over x minus 1. We rewrite log base 10 of x over x minus 1 equals 2 as 10 squared equals x over x minus 1. Let's see, 10 squared is 100. 100 equals x over x minus 1. I'm going to multiply both sides by x minus 1. Distribute the 100 through. 100x minus 100 equals x. I'll subtract x and add 100 over. So that'll give me 99x equals 100. So x is 100 over 99. Is the answer to that second one. 100 over 99. Okay, so that's a little bigger than 1, right? So this will be fine. So I'm taking something a little bigger than 1, minus 1. So that'll be positive, and everything's positive. So we just want to make sure we check our answer and make sure it's positive, because that's the only thing you can take the log of. All right, so 100 over 99 is the answer to that second one. This one, we're going to really be using our properties here. I have 2 natural log of x equals natural log of x plus 3 times x minus 1. 2 logs added together is the same as the single log of their product. Now, what I should have done here, because I have to just have log of this equals log of that, and I can't have this 2 here, but I know that that must have come from the exponent, right? Natural log of x squared is the same as 2 times natural log of x. All right, that exponent can go in front, or we can move it up there. Now, I wanted to move it up there because now I have the natural log of this equals the natural log of that. So this has to equal that. Okay, we'll distribute. We'll get x squared equals x squared minus x plus 3x minus 3. Let's come over here. So x squared equals x squared plus 2x minus 3. I'll subtract x squared from both sides. That gives me 0 equals 2x minus 3. I'll add 3 and divide by 2. It looks like x equals 3 halves, or 1.5. Let's see, if I put 1.5 in here, 1.5 minus 1, yep, that's positive. 1.5 plus 3, that's positive. 1.5 is positive. I'm good to go. Okay. Let's try this one. Okay. Gracious. I have a plus sign here. So to write that as a single log, I would multiply the x minus 1 times 3. I have a minus sign here. To write that as a single log, I would write x over 4. Now I have the log of this equals the log of this. So they must equal each other. I'm going to distribute the 3 through, if that's okay. Multiply everything times 4. Subtract the x. Add the 12 to the other side. X is 12 elevenths. 12 elevenths minus 11 elevenths. That's good. That's positive, positive, positive. We are good to go. All right. Exponential equations that we can't solve the traditional way. We have two choices. We can rewrite them as a log, or we can take the log or the natural log of each side. I kind of prefer this way, but others prefer this way, so I'm going to show them both ways, okay? To rewrite this as a log, I would say log base 1.02 of 5 equals 14 minus 1. Right? We have to be able to go back and forth between log form and exponential form. This is the same as saying 1.02 to the 14 minus 1 power equals 5. All right, I'm going to add 1 to this mess. Oops, I didn't really add 1, sorry. I'm adding 1 over here and then dividing by 4. This is a number. 1 plus log base 1.02 of 5 over 4. We would do that on our calculator and get the answer. The other way to do it is to take the log or natural log of both sides. I'm going to take the natural log. Doesn't matter. They're both on my calculator. The reason we do that is so that we can move this exponent in front. 14 minus 1 times the natural log of 1.02 equals the natural log of 5. Natural log of 1.02 is a number that I'm going to multiply or distribute, through the parentheses. So I have 4t natural log of 1.02 minus natural log of 1.02 equals natural log of 5. I will add the natural log of 1.02 to the other side. Okay, and then divide by 4 natural log of 1.02. And I'll do that on my calculator. Okay, so let's go ahead and do this blue one on your calculator. Take natural log of 5 plus natural log of 1.02 equals, divide that by parentheses 4 natural log. Let me pull my calculator up to show you. Okay, guys, you really have to be careful. We want to put in parentheses. I want to type natural log of 5 and the parenthesis that it came with plus natural log of 1.02. Okay, and then end that parenthesis from the 1, but also end the parenthesis so that I have that whole numerator divided by parenthesis 4 natural log of 1.02. Okay, and the parenthesis there and the other parenthesis. You should get 20.568. Okay, so we got 20.568, and now we want to do this one. We want to go 1 plus, now remember to do log base 1.02 of 5, we take log of 5 divided by log of 1.02. Okay, so that's the numerator. And then we divide that by 4. 20.568. Look, they're the exact same number. Okay, so it doesn't matter whether we do it this way or this way, but you have to be able to do those on your calculator correctly. All right, let's try this one on our own. Okay, so because the time was running out, I did this for you quickly. Okay, these are the two ways, and they both give you 14.2067. Either way you do it, whether you rewrite it as a log or if you take the log of both sides or the natural log of both sides. Okay, either way.